gonna record my part two here. So I just need an assembly. One thing that I'll note though, like if you're working ahead and placing your stuff on drawings and stuff, I'm gonna use I'm going to use, in our modules tab here, the resource. I'm gonna pull this template. It's in the very beginning of our resources for CAD 1 11 22. This inventor inch template here, ISU B size. This is the one that I'm going to use. So you should be able to download this. And then if I open my file, the difference will be I'm going to open that file right now that I just downloaded from our Canvas. If I say open from, I got to go to my downloads here. This one. It's just going to be, there's going to be a few things that I've populated on here. I would say it's not my favorite template. I'm going to use it this semester, but eventually I've just brought in some of the stuff from CAD. And so it has, and it functions just a little bit different the way I enter some of the data. And we can work through that once we start placing on here. But this is the template I'd start using. It has a revision block on it. Pretty similar title block. It just has a tolerance block as well as a note, general note that's I think you can modifiable some of this stuff. So this is the one I'm going to go to when I need it. I'm a little ways off from that yet. In fact, but I do plan to try to get there today. Just so. What I'm going to do is jump in and do a quick assembly here. So it's just going to be a standard inch English assembly. So I don't have one of these yet, so it'll be a new one. What's that? Just assembly, just an assembly. First thing I'm going to place in there is that crankcase. I mean, I can go through and place all those files, my new files. I can save mine really quick. I guess I'll just save it in my in class V Twin. So this is just going to be some name that I'll recognize. CAD 1122. This is going to be my V Twin. I'm going to say like V Twin Pistons. I'll just call it the full name here. So I'll say save. So now I have my new assembly with the V Twin Piston. And I just need to put all those parts in. So I'm just going to go through that and place all of them real quick here. So I'm just going to place them in my assembly. I've got mine saved in this particular folder. So here's my case. Place it. Just place all those. New piston. In fact, I need two of these now. So when you're placing them, I'm just going to do like one click. Now I've got my two pistons. Same part. Just need two of them. And then place. I've got my piston case, piston. They need a wrist pin. I need two of those wrist pins, one for each piston. And then I need to place one crankshaft is all I need. They're all on the same crankshaft, so that's that one. And connection rods. I need two of those. Two connection rods. So this is really similar to what you would have done in the end of chapter 7 if you worked through the problems. You would have just kept it the same size. He wouldn't have had to make you make a 3/4 size adjustment. It would have just been all the same size. So the only thing I've really done different right now at this point is just that I've done a 3/4 scale size on my part size. If I don't love working on my assembly, I like these shaded with edges is how I like to look at my parts usually. So this is happy. So I'm going to ground and root this thing, right? That's how I'm going to start with a steady foundation that won't move on me. So I'm just going to take this thing here, and that's on the Assemble tab. Under the Productivity palette, there is a ground and root, right? Definitely, I 3/4 it. I 3/4 the size of the lane. So I think the piston really is pretty much an 1.5 inch diameter, 1.5 inch long. Because I think they were 2x2 originally. Yeah. 2 inch diameter, 2 inch extrude. Yeah. So I changed mine. So the component I need is this one. I'm going to ground and root it. I'm going to say, okay. So that's actually, now it's ground and rooted. So its origins match the origins of the assembly, right? That's what's going on there. And now the rest, I'll just do the same. I'm going to use the same constraints that we did when we originally applied this thing. So I think remember you can like rotate free if you want to, if that helps you, just like use that rotate free rotate up here in the position palette here. I use yeah, I yep I am. I use keyboard G. I just hit G and I hit my parts and that's free rotate as well. Right. So I'm going to insert this one into there. I'm going to insert the other one in there. I think the only constraint we really had on this originally was just to insert it into that. So it's just like a constraint, a mating constraint, but and I'm just choosing the outer surface. Really, to me, the axis that it's using, whether it's referencing the outer features or the inner features, it's the axis that I'm looking for. So I don't feel like it matters, but just know there are difference. This is the features of the inner bore axis. This is the feature of the outer bore axis. So I'm just going to use the outer bore and then this inner bore here. It slaps it in, and I have it directionally the right way by chance. If it's not, switch it there. But usually you notice it'll snap to kind of where you click, because that axis really goes on forever in both directions. It really goes where it goes on mine because that's kind of where I clicked. So sometimes it is kind of moves those parts into the area where you actually click. And so then I'm just going to say apply that one. And I'm going to move over to the next part here, which is this one. And I really don't even have to move it over. You can, but I'm just going to say, oh, I want its axis and I want the center bore. And it put it in backwards for me. So I'll just swap that solution to that way. I'll say okay or apply. So those two are in. Yep. We'll just stop sharing here. Yeah. How do you grab? Yeah, I would not worry about it right now. But say choose front. How do you edit a constraint? Yeah, your constraints will show up in an assembly. They'll show up under the relationships. If you expand the relationships tab out, that's going to be the running list of all of them in the whole thing. If you expand out the the part models here, they're going to have the constraints that are associated with it only. So I would say I generally make modifications to my constraints from where they lie here, like which underneath the part that they're associated with. I generally don't make too many changes up here. I just know this is my running list of them. I can quickly identify them, but I tend to make my changes from here, and you just like right click and say edit, and you'll be back into the constraint panel where you can actually totally redo the selections. Like if you click on these, it's like wanting you to select first and select second selection. So they're totally reselectable. And the dimensions can be changed and we can measure our offset if we're looking for an offset. Oh yeah, come back. I will. What was it? Yeah. So then I'm just gonna put my wrist pins in. Wrist pin string. Oh, they're gonna go into this board here, right? It's good. Apply that constraint. I think I built these right, and I think I fixed them in the original models because I think if I told you, I liked to constrain this thing so that it was tied into the center of the piston, and so I used the plane of it, right? So if I can identify where this part is over, and sometimes you just select it in your model, it'll highlight in your tree, and you can expand this out and say, oh yeah, its origin had this like center plane that I liked, which was this one, because I extruded it over centered over the origin. So I'm going to end up constraining this plane to the plane of this particular piston. What's that? Yeah, every part will always have its original origin planes if you just expand the origin list. So, you gotta really expand these things out. Your nature of inventor is going to be you're going to be used to expanding all of this. all of the control you can get over these parts, especially in an assembly. It gets to be where if you have like 15 or 20 parts and you have them expanded out, it gets a little bit annoying and they get kind of busy. And you can always right click in here and say collapse all. And there's your original little parts in their collapse form. But really, I'm looking for this part. So I kind of highlight it in my model, and then I come over here and I expand it out, and I say, there's my origin planes for that part. And this is the plane I want to constrain to the plane of this one. So I'm going to select my piston now. It's this particular piston because I have two. I don't know which one's which. But here's this one, and here's its origins. And there's the one plane that kind of runs the way that I would want to constrain. If I was to hook that pin and the piston up plane to plane, this is the plane I want. This one doesn't do me a lot of good that direction. It would stop the pin from rotating potentially, which I don't want to do that yet either. I just want to center it, and I'm okay if it rotates. Right now it rotates because it's just got an axis alignment, so that but but I don't want it sliding back and forth because I want it to be centered in that piston. So this is why I chose this next constraint as this plane, which is weird. This is where I select them too as I come into their list. And even though they're not highlighted, I can just hover over them and be like, that's the plane. I'm going to select that as selection one. Selection two is going to be in the piston plane assembly. It's that one. I just highlight over it for a second. And then if I say apply, and if I get an error, this just says, hey, that conflicts with the existing constraint that's there. I'll say, oh, let me edit the relationship. And I'll say, I'm going to pick this other solution. And then I'm going to say apply. And that's all it was it was just the direction of the axis, the way I had the first constraint, conflicted with that mating constraint of those planes to plane. But if I just reverse the solution, those two constraints are now kind of working together. Oh yeah, then you can't use it. Then you have to use it. So what I would do, this is what I would do, is I go into that wrist pin part. So mine's still open, right? And all I had to, and I changed this on the first assembly, but what I do is I went into the extrusion and the way it extruded. And instead of being from one end or the other like this, I drove it from the middle. And the reason is because that's where, yeah, that's where that plane is in the middle of this extruded part. So now when I say okay, it really doesn't change the part much. You probably shouldn't get any like blowups for doing that. But if you expand its origin within here, you can see that it put technically your part is now kind of built symmetrically over the origin planes. Yeah. If I can do this, I do this because it makes it so easy to align in an assembly to have the origin planes like centered within the part. But not all parts you can do that with. Some parts are a little more complicated, and you end up having to use maybe a dimensional constraint to constrain it, which wouldn't be the end of the world. It just is, I think I mentioned last time that I do use a lot of plane to plane constraints because when I change dimensions, it doesn't change those constraints. It's always minimizing. It's the slight designer in me that's just minimizing data inputs, even though I have a lot. I do have a lot when it comes to these 5 parts. They're not the easiest to modify at this point, but I'm still trying to minimize them as I go a little bit. So that thing's locked in. And so I'm just going to leave that there. Those are really the only two constraints I wanted for a minute. Now it doesn't slide back and forth, but it still rotates. And this thing slides back and forth, and that's good. Just leave it. I just need to put the other wrist pin in. It's over here. So I'm going to do a constraint of the axis to the axis. Great. Great Jimi Hendrix song is Axis, Bold as Love. I have no idea what that means, but it's a great song. When I think about it. So that looks good. I'm going to apply that constraint. And then I'm going to do the same, like sometimes I have to find it in the list before I can even constrain it because they're not always easiest. Like when you're in the constraint, when you have the constraint dialog box open, sometimes some things are not selectable or highlightable until you escape sometimes and say like, oh, this is what I'm looking for. Here's its origin. Here's the plane I'm looking for right there. Sometimes I have to kind of get out of it and then explore my model and find out which piston. Oh, it's not this piston. I can collapse that one and say it's this piston. Yeah, so let me think like if your planes aren't working, how would I constrain this? Well, it's going to be a dimensional constraint then. Like um and it might be a little trickier to get, but we could say yeah, so if I thought of another way to constrain this, um and if this one wouldn't work, I'll delete it real quick so now I can slide it back and forth. I just want to would maybe I have to explore this part a little bit and see what I can measure, and I just want to think of it being centered. So I could say these two faces are a little bit easier to work with to me than it would be to try to pick a point on this contour cut face. Maybe there are some points here that I could pick, but I'm kind of wondering, like what? Okay, so what is this between this and this? Well, this is 0.563, which is really 0.5625, but 563 would be close enough in some ways. So if I would measure 563, then and then I would have to know, I don't know, something. I have to know how long my pin is. How long is this pin? Oh, it's 1.406, kind of a weird odd. So I might bring up a calculator and say, well, this is is it 406? Let me put that in my calculator. What I'm going to do is come up with a dimension to dimensionally constrain it. 1.406. Yeah. And so I might want to know what half of that is. Yeah, I think so. Because what I'm thinking about doing is if for a dimension, I might say, you know, what is half of mine, and can I come up with a dimension of where halfway and half would be? Like what would the dimension be if it was from here to the half point and to the half point on the pin? And I'm like, I don't know, but it's going to be half of my pin is the one. Then how far over to here? Well, it's half of this. So this is the way my brain kind of works is like, oh, this is 1.406. I'm going to divide that by two and 703. So really, the center of this is 703. What is it from here? Again, it's 563, I think. 563. So if I said, I'm not sure I down, I have my little history there, but 0.703. This measures 0.56. 28125. Um, yeah, so now I'm thinking this 28125. If I add it to half my pin, it can kind of be from the end to the. I'll show you how I'll do this, but I mean, it gets a little more complicated to kind of figure out, especially on this kind of shape. 28125. Wait. 2815. Sorry. This is 703 is half that, and a minus 22. Yeah, for to constrain it, you would order of operations. I guess it would be uh, if it's plane to plane, it's going to be just pick one of the planes. It wouldn't matter which one I pick first. So if I go to constraints now and say um, it's this plane, not that plane, I'll reselect here this plane to plane here. Sorry, I don't have that piston one open, but to the highlight. No, it's right there. So, so it doesn't matter as long as you can identify on your list which plane is which plane. That's kind of what I'm doing here first. Like here's this one, here's this plane. So I know it's that YZ plane, and I know on this one here, it's this little part right here, and it's an XY plane. Yeah, it doesn't matter which one I would choose. I just need to identify them first. There's that one, and then there's this. then I would hit apply. If it doesn't work, just say edit the relationship and try the other solution. Hit apply. That one does. I did figure out a measurement for you, but it takes a little figuring. Like you would have had to do something like I think if I didn't have a measurement, it would be like what do I have on my calculator here? 4215. I would see like constrain the end of this to this, but I'd want to be at 0.4215. Is that what I'm talking about that there? 4215, yep. 4215. And I'm going to go the other direction. Nope, I'm not going to go the other direction. I'm actually going to go negative. I'm going to say, okay. That would be my dimension. It took me a little figuring to get it. And so plane to plane is way easier if it can be, but a measurement you can figure out. Like I was able to figure out a measurement to place this pin centered in there. And mine is a negative 0.4215. But it took me measuring the pin length, it took me measuring the opening length, and to figure out the halves of each and then add them together or subtract them from each other. And then I came up with a dimension. Yeah, you do this all the time in assemblies too, is figure out what is the dimension between halfway. Sometimes the plane to plane isn't going to work and you're going to have to come up with a dimension. So you got to be prepared for both. You got to do whatever you got to do. The problem is that's a dimensional constraint. And so if this thing increases in size or I use it somewhere else, this is going to be an issue on a constraint. It's always going to be that much off of that base. So that's definitely not the type I would want unless I absolutely have to have it. Assemblies, when the constraints blow up, they can take you hours and hours to reconstrain things. And that's just the nature of some of these parts and constraints like that. Plane to plane. And I didn't do that one here yet. I thought I did. I already did this. I'm going to constrain them both. Constrain that one to this the other piston, maybe this one. I already did this constraint. Now I have wrist pins centered in pistons, and we're ready for more parts. Yes, assembly. This one has to be in. This one has to be in. This one has to be in. I think what I'm going to do is I'll constrain the. I know we have to make a change here, huh? I don't think I've made all the correct changes here because the original crank was only carrying one. It was carrying this piston that sits a little bit lower than this other one that we redrew second. So I can go ahead and insert this right now. So I can constrain this axis into this hole. That's where this goes. That's one legit. I can say, okay, it still has a lot of movement here, right? I can spin it and I can move it up and down. How the original one worked was this was in here, and then my connection rod, I placed it centered over here and over the top of this. Yes, is that correct? Yeah, because this isn't oriented the correct way that I would be. Is down. So I'm going to take my connection rod. I'm going to start constraining the one that was this is the original bore here. Like I said, this one is a higher up bore. That's the second one we added. So I'm going to go to the original bore and do its constraining first. So I'm going to do like here. I'm just going to pick any hole on here though. I don't think connection rod is symmetrical. I'm going to say this one, fine. That one is going to go on my piston wrist pin right here. So it snaps on there pretty good. I'm going to say apply that. And then I'm going to apply this next hole, axis to axis here. And that snapped in good. I'm going to say okay. I did them both. Yeah. So right now I have axis to axis, but it can really go up and down. You're going to stay aligned in some ways. I think what I did now though is I definitely did. I don't know how yours is built here, but this is another one that I adjusted on my original part. So I'm going to say open this one up back to this one. Just check yourself. I want to use its origin planes as well. So it's centered that way, it's centered this way, and it's centered this way. So if you've made this extrusion, let me edit this feature. I've got mine extruding both sides of center. And this will help me use that plane to constrain on the centers. So I'll say okay. So make that change like you would on the wrist pin if you didn't do that. It'll make this assembly easier. Because the first one I'm going to do is lock it up so it's centered on that wrist pin. So it's really that same center line on this one, which is this one. That one right there. I'm going to line it with the center line on this one. So like I say, it helps to sometimes collapse all these things, collapse them, and then I can just pick the ones I want. Here's one. Here's its plane geometry. Here's my connection rod that I'm trying to constrain. So I'll expand it out right here, and I'll expand this. And here's all of its planes. What are you saying? You have to fix it. You have to fix it. 4.75. Yeah, it should be 5.625, really. 3.5625 is what that finish line. What is blowing up on you? Too long. Yeah. Oh, yeah. It won't. Yeah, that's true. Well, right now it should be pretty forgiving because the piston isn't like even if it was too long, it should be okay still. Maybe it might be busting through this back side if it's too long. Like this thing might. Yeah, and mine is not rotating how I want it to do either because I really haven't. I've only just axially constrained it, but I have no. So I've got to just keep doing some constraints to me. So I've got my planes identified. Here's the wrist pin plane that I'm going to use. I'm gonna constrain it to this particular this one, this plane of my connection rod. So I'm gonna say constrain this plane. That one right there, that's the wrist pin plane. This one right here is the connection rod plane. Love it. Now they're lined up. I'll apply that one. On the other end, this one still goes up and down. I'm going to constrain those two faces together, this underside face and this topside face. That's going to kind of lock in the height of where this really lives here. Like right now, I need this control. I need this connection rod to always stay like linearly aligned with the center of the bore. Everything needs to be centered for this thing to drive through there straight. So that I really focused on like getting this thing in alignment with essentially with the piston case and its center line and the hole through it. Now, because that's what's going to drive where this thing lives, is just it's going to bump up into that. And that's the original design that we did. What's that? What are you saying? I don't know. Right here. Mine kind of moves. It's getting closer. It's three-quarter the size of what it was. Definitely change it. All dimensions have been changed by three-quarter their size. The length has. Even the extrusion width has been changed. So all dimensions were changed by three-quarter their size. And the extrusion itself is actually was a quarter inch originally. Now it's 3/16, 0.1875, if I did that math. And then what I'm going to do is I'm just going to do one more constraint, which is face of this to face of this. I'm going to say, okay, apply that. Yep, that way now that locks in the height of this crankshaft. It has to be right there. The piston, the wrist pin, the connection rod are all centered in the piston case. And now the crankshaft height is just like slammed right up against it. I have no tolerance there right now. I just have like 0. Just slam. And I really haven't done any constraints I didn't do on the last one, actually. push pause. Jump into my recording again here. So what we really got is an order of operations. So this thing, the original bore and the original like this has to be the first one on the crankshaft. This is the alignment that now the other one has to go on top. And of course, my crankshaft is too short. I think if you would have followed, if I didn't follow all my dimensions, I think on my screen grabs, but it would have showed me that I need to add more to this little this distance here. In fact, I think I actually reduced the size to match the thickness of the original. So it's like I need to extend it so it can hold two control rods. And it's not the end of the. I can do it in just a second. I'll show you. First, I'll just get the connection rod. I keep saying control rod. We're not building nuclear reactors. Building a piston, so it's a connection rod, not a control rod. But about the same kind of. We're making a reactor of sorts here. So I'm going to constrain the planes on this wrist pin to this one here. So if I need to identify those, just a quick collapse solve here. Here's my wrist pin part. It's this one. Here's its planes, so I have them exposed. And then this one here is the other connection. I'm going to come here with its planes exposed. I'm going to do a quick constraint on the correct plane. It's this one. Going to constrain to this one. Snappy. Yeah. And that one, I guess I could have done the axle or the axial. I'll never say that. I'm talking about multiple axes. See that side? Octopi. I got to constrain that to this too. So I've already got on the plane. That's good. It likes that. The last thing I'm going to do is I'm definitely going to do this to the crankshaft. I need this thing to be to this crankshaft. Here's one that if you have parts bearing parts, yeah, you can go to wireframe. I never do that. Here's one thing. You can just select the part and just say, turn off its visibility. And so like that, the only reason why is because I'm looking to get into this. So you can just turn off the visibilities of parts if they're in your way. I think that's why I want to do that more than anything. Just hide them for a minute. Then I can select this axis and this one. And that's one thing that I want it to be aligned. So I'm going to say apply. And then you notice if you ever turn off the visibility of your parts, there'll be like a shaded little box over here. They'll look like a wireframe box on your tree. That's how you can tell when things are turned off. If you just look down through your tree, you'll be like, oh, this part is turned off. And then you just right click on it and turn on its visibility, and there it is again. So kind of easy to get something out of your way, to use some geometry to align that maybe just need that part out of your way. What's that? It was just the visibility of the part itself. Like, yeah, I'm just like selecting the part, right clicking, and that's how you can open it to go to the part file. But right here is just its basic visibility. Yeah. So we can just turn it on and off. The problem is once it's off, where did it go? Well, just look over here on your browser and look for the blue part file icon to be like a wireframe looking thing. And you'll know that part's kind of invisible. Yeah. The last thing I want to do here is I just want this, maybe that's all I've got to do, because really it is kind of locked in. What you would want to make sure, one thing to know that if your sizes are all working, is that like this face to this face, I haven't actually constrained those two together, but I'm going to measure them just to make sure they're like zero. Like if my dimensions are all right, and this one is now aligned with the planes of this piston, this one's aligned with this planes, and now if I measure between like this face and this face, I should have like zero. If I don't have zero, if I have a negative value, that means they're interfering with each other and I've got an issue with my dimensions. If they're more than zero, it just means that one of these piston centers kind of is higher or lower than the other one, and it's probably that 1.03125 dimension that is driving that. It's how high I put this off from here up to the center of the door. It really mattered, right? Like now that I have two together, they have to be at the right height distance. So the only thing is I don't have any way to grab. I mean, like this shaft needs to be extended up through here. And it needs to be extended not just through to flush, but through that I can also put a fastener on it to hold it. Because now we're going to start to think of, how do these things even stay together? How do they stay in position? There's nothing holding them there. I mean, my constraints are holding them there, but that's not reality. And right now they're all size on size, so they fit like the last assembly, which is not good either. So now I'm at this point where I need to make some real adjustments to make this thing real work. The first thing I've got to adjust, I think, for me is this crankshaft. So it probably was one that if I go back to here and just in our assignments, it was just I think I glossed over that and I probably didn't make my point. So I go into the V Twin. I'm going to go to the crankshaft images and just see what the dimensions I put in it are. I think I made all these adjustments. I just think I missed this right here. And maybe I didn't even, did I put it in? Oh yeah, maybe here I show this one I went to the long one I made 1.6875. That's 1 11/16. And then the short one I made zero, yeah, 0.51 for some reason. So I'm going to do that. I'm going to make these two adjustments here. Just take a quick screen grab of those two shots there. And then I'm going to go to that part and make that adjustment. So, I mean, you can go in here, right? And we said we could always do like an edit here. I can edit this part. It doesn't let me edit because I have it open, right? Okay. And then we remember that from the other day. If your edit right now is grayed out, it's because you already have it open. So you can either close it and do the edit, or I'm just going to bounce over to it and do the edit over on it. So I'm just going to say, well, I'll just open it, which really just moves me over to its open file. And I'll make these extrusion adjustments. So this one here, instead of being like the original size times 3/4, actually need it longer to carry the other one. And it's kind of an odd dimension, but it's 0.51. And we'll see if that's what it ends up being. But that's at least, yeah, 0.51 is kind of the shorter one. That's long enough to hold two connection rods for sure, and potentially a fastener. So I probably had to adjust that height. Let's see that dimension. 0.51. The extrusion, yep, is 0.51. So I got rid of the original dimension and added that one in. And then I'm going to change this other extrusion dimension to, it was the one that I also was timing by 3/4, but I'm actually going to say, oh, it's 1.6875. This could change, but I think this is this way because, so I'll say okay on this. This is the one I put my little handle on and stuff. So I think I had to bump its dimension a couple of times to play around with it. But now I'm going to go back to my assembly. And those, I've got my little update thing. Really, it already looks like the updates happened, but I always just click my update button and things are settled down. The update is on your quick access. It'll be a lightning bolt. A local update is what it will show. So just watch for that to kind of show up. Sometimes it'll show up in your model browser too. Like it can show up on the part itself, or I think maybe something here was, look for those little lightning bolts though. That just means an update needs to happen. It kind of reminds me of that lightning bolt that was used in CAD for annotation or not. It had a little lightning bolt update down on the status bar. So if you save this now, like this is a regular thing too, like because of the stream of connectivity flow here, the parts in the assembly are talking to each other. If I hit a save, you get these like it's, hey, I'm going to save this, this, and this. And so if I hit OK, it's going to save. It's going to save the updates to the parts that are in this assembly too. That's not, because then it's just like saving everything downstream from this assembly, making those updates saved. So now at this point, we're ready to like explore how the freak we would pull this thing together. So I think what I'll show you is on my part that I handed around to you. If you want to pass it back around, look at it. It has these little things that are called snap rings, and they're a pretty common automotive little part, like a hold in place position part. They're kind of cool because they can take a little force load. They can kind of work as kind of like a little thrust. And so they do have some, they are like a spring steel, so they're kind of a special material that allows them to thrust load, meaning that they're meant to like hold things in position, but if things like rub up against them, they do have some strength involved. So they have a little thrust loading strength. These are really little ones for those. So they take a special tool to use. There's two little holes in them, and it takes a snap ring plier to open and close those. And so there's some special, so that when I looked at this assembly, I thought, well, how am I going to hold it together? I just thought, oh, I'll just use snap. And that was great until I tried to assemble them. And then it's really hard to get the flip and snap rings into here. You'll notice mine, I only have one on it. the one reason why it's hard to get there. And ideally, I would like to have these snap rings. So I mean, you wouldn't know this, but I like to talk about this because it's like going in fastener line here, and it's like, well, what I'm thinking about is, okay, well, how do I hold this thing together? So here's a piston, and here's a rod through it. There is in the real world, I know we have constraints holding it together, but in the real world, this thing will just fall out. Like, this thing is going to, well, that's crazy, but too crazy with it. But once it gets to here, that pin is going to fall. Boom, it's just going to fall out, and then it's going to fall here. And then you're not going to be able to go in because the pin just fell out. So you got to think it, unless there's tension, and we don't want too much tension. You can kind of see that this thing has to kind of have some slack, it has to have some tolerance to it because you can see how those control rods or the connect. I'm going to notice how the connection rods kind of rock back and forth to make that motion. So you can't lock that in. That thing always has to freely move. So we have to have some tolerance on the wrist pin to the connection rod for sure. We don't want the wrist pin to just fall out when this hole is exposed and out of the cylinder door. So I've got to have something that holds that in. And then because this is like 3 to 4 inches away from this to here, in the real world, if I just set this here, this thing will probably sag down and it'll maybe get jammed up on itself. So when I looked at this assembly, I was like, well, I need like a little something to, that's why I thought of a snap ring, is because of my experience. I'm like, well, I'll just put a snap ring here on the top and bottom. That'll hold the connection rod centered always on the wrist pin. And then to keep the wrist pin from falling out, you would think that would do it. But even if I control with the fastener the wrist pin and the connection rod, and so I keep that centered, well, what's going to keep those still from falling through? Well, to me, it's like, well, then I need a little snap ring in this hole as well to hold the rod from falling out. I don't have that in mind passing around because they didn't have any of them local. And I'll show you what I mean. I kind of need like internal and external snap. This one I need a fastener that snaps on the wrist pin here. And then I need one that snaps into a hole. And those are called internal, external snap rings. They make them, which is a standard part. So I was thinking to myself, I'll do that. And that'll be great. The other thing they make for external kind of snap rings is they make one that just snaps over the shaft. You don't have to have a special tool for. You don't have to have needle nose pliers, but it kind of is open on one side. It just clicks over a shaft. And after putting one together, I was like, I'd rather have an external snap ring like that. The one that I don't need a special plier. I just need to be able to insert it from this end of the piston and snap them in. And so cool. So having built a prototype, I realized, and having to try to assemble one, I was like, it doesn't work good. And so I think I'm going to use a different piece of hardware there. So to me, it's like I need like 4 pieces of hardware to hold all this in alignment. And then I come over to here, and I don't want this thing to pop off this shaft. So I can put another snap ring on the top here to hold these from lifting off. And that'll be good. I might need to put one here and here to hold this crank thing from falling through, because this thing would just slip back and forth through here. So I'm going to put a snap ring here and here to hold that thing in alignment, and then a keeper to keep those two together so they don't fall off. And then I need the same 4 through here. And then eventually I want to be able to just maybe, in mine, I was like, I'll just turn it here, like when it's on my table as my fidget toy. You could make this where you turn it to from the top side, but you would still have to kind of pin through here for stability. So what I did is like, okay, I'm ready for fasteners. So this is what we're gonna do. I'll show you how you work with fasteners. I don't need to draw that; they already exist. McMaster taught it. So I go to my website. You guys can all do this too. And what you need to know though is some sizes associated with what you're working with, right? So if I go back to my real quick screen, these are 3/8 diameter shafts. The wrist pin is 3/8, 0.375. This little crankshaft pins, or all of its shafts are 3/8. So I'm looking for a keeper for 3/8. And so when I jumped over to McMaster car, here we go. McMaster car. I don't know which I'll X out here. So if I just go to the main page, maybe it looks like this. It's got everything your heart desires and more, and 3D models. Yes. We're looking for snap rings. So I'm going to type in snap rings, SNOP, snap rings. And then you can see, oh, if you don't know these exist, that's a hard thing to know what to look for, right? But snap rings, they're kind of retaining ring is what they're for. And that's what I want to do is some retaining. They kind of show you some imagery of what maybe some options I have. A lot. Like you now that you know what a snap ring is, you'll see them. They'll probably pop up like if you say like look for a red car, look for a yellow car, you'll see them all the time. Yeah, you'll start to see, but they're pretty common, and they make some different ones. Yeah, like this is the one that I said, like this side mount style is what I definitely want to assemble the wrist pin to the piston and to the connection rod. The one that I have to go inside the piston to snap on, that's a hard one to get into. And so I'm going to pull a couple of these ones. Here's a standard one though with the little pins. That's if you pass mine around, they're all these little standard ones. But they also make an internal one too, which I don't see right away. But they do show that there is a way to hold like an internal snap ring or an external. So for my first, maybe I'll just look at the simplest design here. Is maybe we'll look like at putting one on the top right here. So that's an external snap ring. It would be 3/8 to hold those connection rods onto it. So if I go over here, say, oh, it's an external, you can kind of start, I don't know. This is nice to just kind of pick from top down. If you know your diameter, if you know it's in inches, that immediately eliminates metric stuff. So I'm not looking for anything metric. Looking for, I think this is the OD diameter that I'm wondering. Mine's 3/8. So let's go down here. If I see 3/8, there it is. There are a lot of different sizes. There's a 3/8 OD. And then it's like, okay, are you looking for an internal standard? I'm just looking for a standard originally right now. So there's a standard one. And now it pops up different material types here. I feel like if I look at what populated here, I have different materials in the next one down. I'm just going to do a simple carbon steel one. Yeah, I'm looking for just the simplest standard one, maybe just carbon steel. They'll be cheaper. Anything with a fancy word like that, it's probably gonna be more expensive. And then ring thickness isn't too critical to me at this point. I'm just kind of looking for a standard one. So here's external. I like the first one in the list. I'm not going to look for a mil spec one or a self-locking one or a bowed external. I mean, these are specialized for more specific applications. I'm looking for just maybe this standard one. I have black phosphate, or I even have a zinc yellow film coated one. I think I'm going to do the one that I pass. I think it's just a one. They might still be a little cheaper than these other ones. Yeah. So if I just select this, yeah, and I'm gonna order some. I haven't ordered it yet, but you'll be able to. We've got to work through a little tolerancing yet still, so we're not quite ready to print an order yet. But we're good. And I do feel like, yes, I'm gonna order a pack of 100 of these. But what I really want, whenever you do work like this, where you're pulling in, like this is, I would call this like a buyout part, or this is like I'm not going to manufacture this. I'm going to purchase it and use it in my assembly. Really common. And so I'm going to pull in their data and everything for this so that I know how to order it. But I want the model for it. They already have a model for this. So if I step down here, it's a 3D step file that's going to be compatible with Inventor. Obviously, if I was working SolidWorks, I'd pull into SolidWorks file. I have some other file types, some 2D file types. Really, I'm going to pull in this 3D step, which is just a step file. It's just a really compatible file with a lot of different programs. So it will work in Fusion, it'll work in Inventor, it'll work in SolidWorks. I feel like it's just one of the most readily acceptable file types, the step file. So I'm gonna just select this and download it. So I want the step file. I want to download. It should download to your computer to your downloads. I'm going to come back to it, but I want to pull one more thing that I want here. Here's what? Oh, yours, you couldn't pull the step file. It's like this. It's probably like there's some. Oh, it thinks we're all hackers. Yeah. They, otherwise, we're going to get flagged for hacking McMaster-Carr. They're going to be like, why is ISU 15 students at once? Like, yes, this is like, yeah, this is actually this company is freaking amazing. And you know what? And they did Amazon shipping before Amazon shipping even knew. They were overnight shippers like way before Amazon. Like these people like own shipping. And they still are fast shippers actually. Yeah, you'll find in your industry. I mean, oh, this is common. What I'm doing with you right now is freaking you. You know, the modern drafter designer is not. designing we are beg, borrowing, and stealing from anybody that's already done our work for us. And for buyout parts, it's always that way. Whether you're in Revit buying windows and doors, generally you're probably not having to draw that window from scratch. You're going to pull its model from the manufacturer. Yeah, 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 yeah. And it's just you don't know that like almost every manufacturer of parts is really they really are already like knowing that people want their models for models, and so they're really available from a lot of manufacturing. Whether it's belts, chain, like the stuff you're reading about, you'll be able to go to their, if you knew the chain manufacturers per se, you could go to their websites and pull their models. There are some things with MasterCard that are kind of not maybe not the best. There are manufacturers out there that specialize in things that yes, McMasterCard sells them, but maybe they're not the best quality. Fasteners are really good at, so I think they have good quality, but there are some things that are not McMasterCard isn't for everything. Yeah, I don't know if like gearboxes off McMasterCard. I'm sure they have some. I might be going to the individual supplier of the gearbox so I don't get a Chinese made. I don't. Yeah, I agree. Oh, there you go. This is the other thing I want though here. I want this product detail. I want to know the details of this because especially because I need to build my model out. So I'm going to click on here, and this just goes into yes, some prod. But what I want is I'm looking for a document to download. So I really want this. I want the spec sheet for it. So if I click on this, it should just come up that I can download this. So this is another download I want to do. I want to download this sheet. I want to save it. At least download. I'm not printing it necessarily. I'm just going to save the file. I'm going to save it in my file where I'm working. This is how I know how to modify my model to accept this fasten. I need to know these dimensions, and then I need to the way this works is you cut a slot in your shaft that'll accept this little snap loop. So I actually have to make a groove cut. And I don't know if you can tell that in my little thing passed around, but those little snaps there's a little groove that's cut in my model so it'll accept this. So really, I need to know this, and this would be pretty common. Anything that I usually in a buyout part that I might be using in a model, I'm always going to try to pull its spec sheet with it. I don't want to have to go searching the web for it later. While I'm in pulling a model, I'll definitely pull its spec sheets and then save them in my file so I have a quick access to reference them. So this I'm saving in my in-class V Twin Piston file. It kind of and I don't even change the file name. I'm just going to leave it. This is the McMaster car number. I think it shows on this print, this 9763A170. They have that in their parts description. External snap ring. I'm just going to leave it the same as this. Kind of easy for me to identify. Plus, it has the part number to order already on the file name. Yeah, so perfect. So that's cool. What's that? Let's see here. Yeah, I'm just like in. If I go back, I'm going back to clear McMaster-Carr 101 right here on the main page. And I typed in snap rings. Oh, you did get off. Oh, cool. Oh, yeah, yeah. Yeah, sorry. Now I made it even more complicated than it is. I'll get the standard. It's this one. It's 3/8 black phosphate. It's right here, product detail, right? They kind of have a hidden. You're getting left now, are you? Yeah, this is the one that expanded my product detail page. And then all of these, I think, if I hover down to this one, I feel like it was the savable one. These other ones were just visual images. It's very small, easy to lose. I have two of them in my carpet. Yeah, I don't know. Because snap rings are notorious for flying off. Their tension, they're spring steel, so they're kind of springy. When you load the tool in those little holes and you like expand them or contract them and they fall off, they fling like a flipping, they'll poke your eye out. So I did lose two while I was assembling mine. They're in this carpet, which small children get lost in this carpet in this room. So those little snap rings, they're gone, man. And I had one like hit the ceiling and fly. I was like, well, that's gone. So and then I saved. So I selected this file and I saved it right here. Yes, it brought me up to this place where I could save. So I've got it in my file folder system. That's killer. That's not the only part I want though. That'll do external. So if I go over here, I'm going to put one of those on here. I'm going to put one of those. right here, and right here. So I'm going to need three of those. And then I think I told you I didn't like them here. Like they would work here, but they're just hard to assemble. So I want to be able to just slip in that pin, and I need it to have some kind of grooves and something. But I like the other. I think I'm going to like the other kind of snap ring for it. So I'm going to go back to McMaster Car. I'm going to pull its files too. Oh, one thing I didn't do yet. You did download the. If you were right here and you had the 3D step file downloaded, and you hit download, that's going to be in my. This is funny. This is. I always remember that. I always feel like I'll just jump over that really quick and out of it. No, it's in my downloads. Here it is. It just lives in the downloads on the hard drive. I want to dump this in my file as well. This is the step file. And so this is the first thing I downloaded was the step file. That was 3D step file. And so I'm going to move that to I need to move that to my folder wherever I'm going to keep that. So here's my week 3 stuff. Here's my V Twin. I have one more folder. I got to drive down quite a few folders. I want to dump it in where I'm keeping my parts, essentially. It just becomes a part of my assembly. So I'm going to just pull this thing into my folder, drag and drop it. It's making a copy of it. But essentially, I want to have the PDF in my folder of it and the step file of it ready to go. I need two more types of fasteners though for this assembly. I need an internal one, so I'm going to go back out to maybe just the snap ring. So now I'm just snap rings. I'm back out to the main panel where I have snap rings typed in. It's like I'm doing a new search. Well, this is an external one, same size. Like I mean, maybe it's I'm going to go the same size. It's 3/8 as well. The shaft is the same 3/8. But I'm going to do the side mount one right here. Instead of the standard, I'm going to do the side mount. And it looks like that. These are easy to install. Um, Maybe easier to fall off too, but than a snap ring itself. So there are some reasons why I wouldn't. Like in an actual engine, I might worry about this thing falling off and becoming. So this wouldn't be a great. This is good for a plastic model. I wouldn't want a fastener that could fall off in an engine necessarily, but I'm kind of like breaking the rule a little bit here. Yeah, and these are still metal. I don't even know if they make plastic ones actually, and I don't need heavy duty. I just need this side mount one. And I think I'm going to keep it with the black phosphate kind of finish. I'm not going to do any of these other fancy ones. They get substantially more expensive. Here's the black phosphate that's 3/8. And I'll have the same thing. I want to go down here and I want to download the 3D step file. So I want to download that. And then I want to download its product detail. It's going to be a little different. It's going to have a little different dimensioning to make this thing work than the other. They're just slightly different. But so I'm going to download this spec sheet. Download. Should I go back? Yeah, so I did side mount and then I didn't really pick a groove diameter necessarily here. I just once I picked side mount, I went down to this first one. I'm not picking a low clearance one or a heavy duty one. I'm just picking the side mount external ring. And then there's my 3/8. I already picked the size, so I just want the black phosphate one, the cheap one. I'll buy them in packs of 100 as well. And then I downloaded that step file right there. So I have that one downloaded. And then I'm doing my product detail sheet right here. So I'm going to select that. And then I just want this sheet right here, this one. I want to save it. I'm going to save it in the same file. And I'll just leave it the same file name. It's got its part number in it. Cool, save it. And now when I go to cut my groove and everything for that, this is the dimensioning I'm going to use for sure. Okay, so that one's done. What's that? You can't, I don't even need to do that. I can just I'll show you how I work my, I'm going to pull one more and then I'm going to go in and pull them into my assembly. So good. Yeah, one more. What I want is, I think I told you that the kind we've pulled are external. There's an external snap there. I'll use those other ones right here where I can insert them and just snap them on with some needle nose pliers, pull them off pretty easily. And then internally here, if I pull this back out, I want an internal one to snap in here to keep this pin from falling out left or right there, kind of. So, um, so I'm going to go back to McMaster Car and pull an internal one. It's the same size. If I just go snap ring, I'm going to go back to the main snap ring page. And then I'll go back through and select my 3/8 again, the 3/8 size. Maybe they don't make an internal. Yeah, they do. Do they? I don't know. Let me see. I might have to get a little more selective. Inch. I have to go back a little further. Yeah, I'm gonna maybe so before I select size, I'm gonna select internal, but I'm just kind of wondering, do they make a 3/8 internal? So here's my internal retaining ring. Yes. And I'm gonna do this regular internal ring, just this, yeah. So I'm gonna do this one. Now I can pick the size, right? I can even pick it here if I want to. There it is. Black phosphate, first one in the list. They sell them in batches of 50. This is an internal 3/8 snap ring, black phosphate. I'll download its step file, download. I didn't move that other one too. I got to go move both of those. And then I'll pull the product sheet too. So we pull this product sheet. It's going to be slightly different. So I'll say, save that thing in the same folder where everything else is. Here's my internal ring with its part number. Good, save. Okay, I've got my spec sheets. I've got my 3D models. The last thing I need to do is go to my download folder, and I've got these last two ones that I just downloaded, the internal and the side mount one. I want to dump those into my file as well. So I'm going to make sure that I can get to my in-class V Twin. This is my folder I need them in, so I'll just select both of these and make copies of them in my folder. That one, right? This one? In-class, whatever. So now I should have 3 step files, 3 PDFs of the specs, and now we can go start using them. So let's go, I'm gonna go over to Inventor, and this is how you work with a step file. I'm just gonna open it. So I just go home. I need to open a file. Because what I'm gonna do is kind of convert it to an Inventor file. That's what's gonna happen. I could insert a step file into my assembly. That's actually not a problem. But the first thing I'm going to do is just going to have Inventor just make it into an Inventor file. And so let's do that. Let's find what I want to open. Mine is going to be in my folder where I saved it. Not that one. Yeah, I'm buried pretty deep here, but I'll find it. It's right there. Now it's by default, it's looking for Autodesk Inventor files, right? And I think that's pretty standard default. All you have to do, like, so you don't see your step files, even though I know I've dumped them in here. There are different file types. So I just want to change the file type I'm searching for to a step file here, or all files. This helps a lot. Oh yeah, this is me just trying to open the file that I saved. So like it's I'm on the home tab doing like an open. And then I got to find the file. Mine, I downloaded them. If you didn't move them, they'd be in the download file, which would be fine. But I get a habit of always saving the OG step file in my folder structure usually, so I can always go back to the original file. But so I'm looking for it. Mine is here somewhere in week 3 in V Twin Piston and V Twin Piston in class, but it doesn't show up still because you gotta look for that type of file. And by default, the open and Inventor is going to look for Inventor-based files, but it'll look for all files here. I generally like expand this list. There's all the different types of files that you could look for. I guess on the bottom is all files. And now I see my PDFs and I see, not that I could open a PDF here necessarily, but here's my step files. And I'll just do the first one. It's an external ring. I don't know which one. Was it the 370 or sorry, was it A170 or yeah, the side mount or the other external ones? There's my internal one. So I'm just gonna do this external one. The first one we downloaded, that one. And I'm just gonna say open it. And then it gives you kind of a dialog box of like, you can manipulate how it comes in here. So because right now it's gonna convert it to an Inventor file. And so like that's what it's saying right here. I'm importing type and I'm gonna convert this model into an Inventor type. I can choose to like keep it as surfaces or solids. These are just default. I'm not going to change anything right now and how I want to filter what it looks like potentially. I'm going to let it assume the Inventor unit lengths. I guess I could give it some different, I could name some, I don't know. I could do a lot of different things here. I'm just going to keep it default and say okay. And this thing should show up as a little Inventor model now. So if I say okay, there it is. What's up? And it kind of gives it its name as that. It is an IPT part file. If you notice, it changed it to an IPT part. So if I save this, I'll just hit save. It is a new file. It's not that, it's not, well, it already gave it that name. So that's it. Like actually, this should now be, if I go look in my folder structure here, in in class, yeah, I should now have a. I was thinking I'd have a little. I don't know. I think this is it though. Just hit save. It didn't ask me to do anything weird. Let me close that. Let me go look real quick in my folder structure. Oh, it did. It's got double like here, huh? Oh, I don't love that. That's kind of buried. But I could say so. You know, sometimes you rename stuff that you've pulled in. Sometimes you leave the original manufacturer's name. I mean, different companies will do different stuff. Some companies I worked for, we wouldn't leave the part named like it was. Like we wouldn't leave it its default name. We'd probably bring it into our local company and give it like a part number that would match our other systems. But in its I properties, I probably populate the McMaster car information in the file itself. So right now, I think what I'm going to do is just open that thing back up. Sorry, I shouldn't have closed it. I'm going to open my part back up. It doesn't want to see that. Sorry, it's going to open up a new version of Inventor. I don't want it to do that either. If you ever get two versions of Inventor open, I would close one. Is that what it does? Yeah. Sometimes they're not totally modifiable either. But I'm gonna go back and open my part. Like you said, it's in my file, but it's in a file in a file. It's really buried. There it is. I'll open it. Maybe I'll do a quick save as. I'll do a file save as. Yeah, that's fine too. You can do that. You can just dump it out because I would want it to live like here with my other parts, right? So I have this. Maybe I'll just get rid of it. It looks like I've done a couple of times because I have a copy of two of them. I'll keep it the same name. And now this thing, like you did, whether you moved it or drug it and dropped it, now mine is here somewhere with that name right there. It'll show up in my folder with all the originals. So yeah, I can leave this here though. I wouldn't delete this necessarily. But I may not be needing that anymore either though. A lot of times in my file folder structure, I will build an obsolete. You've seen me do this before, right? I sometimes will build like an obsolete. Sometimes I go like ZZZ obsolete. So I have this folder. I'm a hoarder of files. And so if I'm like, well, I don't want to get confused with this one and those ones, I can just bring this down to my obsolete folder and dump it in there. This is where I'll dump stuff that I used at one time and didn't use anymore, but I don't delete it because I hoard files sometimes, but I just don't need it. And it's a small file anyway. So yeah, this is it. I've just kept the same name. We can actually insert this into the assembly now. So I will come in here. It's just like placing a part file. Place. Here it is right here. I'm going to place it in there. For this particular crankshaft, I needed three of these, so I'll just drop three of them. Okay. And then what we want to do is we just want to constrain that thing. I'm putting them on the crankshaft, so I'm not putting them on the connection rods per se, but I am doing like a constraint. I'll just pick one and its axis here. Bam. And I'll say I'll put one on this crankshaft first here, sure. Right there. I'll say okay. So you can see that this is where it needs a groove for this thing. This thing needs to sit in a groove on this shaft here. This thing can go up and down on here. I need to know like how should I sandwich that down? Should it be just like hard like this, or do I need a little tolerance here so that these parts can move together? Right now I have zero tolerance. That thing is just on that. This one is face to face here, all of these, and then here's this little part here, and so I don't know. You have to come up with like what is the tolerance here? Well, some things you know, some things you don't know. Sometimes it matters on how my 3D printer prints versus how your 3D printer prints. What is the type of material that you're printing with, and what is its normal tolerances? There's a lot of things that go in here to make this thing fit on here. Takes a little bit of like brain power here to figure this out. So one thing I searched because I was like, I don't know. I haven't used this printer that much actually, especially for trying to put things together that are kind of I would say need tolerance or need a pretty tight fit. We're kind of into that realm here now. And so I did like a quick search. This gets pretty long-winded. I'm probably going to stop this pretty soon and say part three is coming your way. But I'll just finish this little concept here. Is like I went and I said, well, what's like the like hole to shaft, hole to shaft on ABS plastic 3D printed. Like, what is the tolerance? So I don't know. I just said like, I'm gonna let Google tell me potentially. Oh, I don't even know if it will. I feel like I looked this up one time and it said it was like I just want to kind of down and dirty number. Yes, I think I should. It's that the world of AI. It's refining your prompts. Always. Minimum tolerance condition would be a minimum sized hole, a maximum size hole given its clearance. Blah 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 blah. And I feel like that's still a mouthful. I feel like I don't know what my prompt was last time I searched this, but it seemed like it was a little straighter. This is maybe one of my old searches. Ah, there it is. This is I use 3D printing ABS tolerance for shaft to hole. Came up with this. This is a 0.2 millimeters. It said maybe with the, and that's just a guess because I think it's different from machine to machine for sure. It takes some. I think it takes some. This is how you sometimes have to know your equipment to know how to work with your equipment. And so our printer might print a little bit different than your home printer. I don't know. It's just it's kind of an experimental phase for a minute to see. Um, but it would be different if it was metal to metal than versus plastic and 3D printed. I'd have to consider both and what is it, and what is our real tolerance on metal and what types of metal. It all kind of maybe plays a factor in what's going to fit. They say 0.2 millimeters, so if you don't know what that is, you can always do a millimeter to inches search real quick. It's telling me that this is like a 0.02 millimeter. So technically, it's saying that that's really a tight tolerance, yeah. 0.0008 if I rounded that up to the fourth decimal place. 0.0008. Almost 1,000th tolerance. I feel like that's pretty small. But let's take a look at what that looks like. So I'm just rounding this tolerance. They're telling me you should probably at least tolerance 0.02 on a shaft to hole relationship. And in my mind, I kind of use that as how far I might put this clip away from the surface that I'm like holding together. I also used this dimension. So what I mean is I'm coming in here and I'm saying, well, how far do I want this? Do I want it to slide right down into the face of it? No, I don't think so. I think I want this to have like at least a 0.0008 clearance, according to on my web search. So I can at least initially like place this thing, like constrain this thing. Um, yeah, from face to face, like from here to this other face. If this gets hard for you to do, it's easy to like get out of the constraints. You can pull this away so I can get to this other face. But what I'm kind of considering is like a constraint from this face to this top face here. Instead of being slammed down like this, where I could get some binding, these are all slammed together now. And if my groove in my crankshaft is right there, then I don't have a lot of tolerance creep. And I'm slamming like two parts and then a thing. So at least I want the minimum tolerance they're telling me maybe on Google 0.008. Is that what it is? No, it's 0.008 like this, right? And then I'm just making sure that's kind of creating a gap here. Say, okay, I mean, that is a tight tolerance. Like I can take a look at this, view this, half section view this thing. And maybe I'm going to come in from like this phase here somewhere, pull in here. This is how I check my tolerances and how I get a feel for how things are fitting. There's a little bit of allowance there. I feel like it's probably a little too minimal, but that'll be fine. It also shows you how that shaft needs groove there to accept this thing. So in order for that fastener to work for me, I need to put a groove on that shaft. So that's kind of what I have to do. I'm gonna go ahead and say I'm gonna X this out and say I'm gonna leave that there. I'm gonna apply these other two that I have in here, right here to here, and then I'm gonna stop this video. But at this point, I've kind of got them on the shaft where they go. with the minimum tolerance applied. And then I'm ready to start cutting some grooves in these shafts to fit those. But when I go to cut those grooves, I need to know for sure, in my assembly, I'm going to be able to come over here and measure where it lives. That'll help me. Like if I'm looking at this, think of this. This is what you got to do. Here's your shaft. You know which fasteners go on it. You know roughly about how much gap you want to have between the stuff. So you're able to come in here and sketch that out. Like I could pick an origin plane here. And I can't remember how I did mine for sure, but I'll go back and look at it. But essentially what I need to do is cut those grooves, and that's what those data sheets are going to be for. This is the external one, my external data sheet. I'm going to open it up real quick. This shows me that it's 4 3/8 OD, but I need to cut this groove this diameter, 0.338, plus that or minus that. I'm just going to put my groove in at this diameter. This is actually what we call the basic diameter. Here's the tolerance potential, but here's the basic dimension. I'm going to use that as my target dimension. And then I need to know how thick that groove is going to be. It's going to be this thick, 0.025. I'm going to use the basic dimension to model to. So that's what I'm going to do is I'm going to find out what the location on that shaft it is. I'm going to apply some cut around that shaft, whether I just draw something in and I do like a revolve cut or something like that. So I'll pick that up on my next video. I'll keep going and get these things put on and get these things cut in. I know for sure that's where I want to use these particular fasteners, is in this easy to get to open environment here. But then the other thing I'm going to do is I'm going to come in and place those other fasteners in that are the snap-on style. And then I'm going to place those with the minimum tolerance away from this, probably 0.0008 away from this face and 0.008 away from this face. Then I got to go into that part, cut the groove to fit that particular part. And then I'm going to take this piston and I've got to figure out essentially on this piston for that internal snap ring, I've got to figure out where this face is to there and space it off some tolerance and then put in my snap ring that goes internally here and cut an internal groove in the piston to accept the internal snap ring. And then I've got to assemble all that stuff. And yeah, that's what I'm going to do. So I'm going to continue on and keep recording today because I'm just going to plow through. Tomorrow I'm going to start doing my drawings. Each part has to be put on that drawing template. When I do that, it's going to be the whole assembly on one, and I'll show you how to do a parts list and a BOM for it. And then it's going to be like break down these parts and dimension them like we would AutoCAD drawings. Like 3 views, isometric view, start dimensioning these out, place center lines on it, do the whole ASME 9 yards on dimensioning. So it's going to be, we got ways to go. We're just getting there. So the fun part's almost done. The work part's just about ready to begin. Build my drawings. So yeah, and I will continue them tomorrow. I'm still planning on getting it done by Sunday night. So pause here. I'm going to go into